rocket is fired vertically with a speed of 5 km per second from the Earth's surface. How far from the Earth does the rocket go before returning to the Earth? Mass of Earth is 6 into 10 to the power 24 kgs. Mean radius of the Earth is given to be 6.4 into 10 to the power 6 meters, and the value of g is given. So first let us take this rocket to be at the surface of the Earth. Let's say this is the state 1, and after going to the top point in its projectile, it comes to rest. And let us say this is the state 2 of the rocket. At state 2, it is at rest. So kinetic energy of the rocket is 0, and all the energy which the rocket possessed in state 1 is converted into potential energy in state 2. As the total energy of the rocket is constant, so we can say total energy in state 1 should be equal to total energy in state 2. Total energy in state 1 is the sum of potential energy and kinetic energy at that particular state. So it is potential energy at 1 plus kinetic energy at 1 should be equal to kinetic energy at 2 plus potential energy at 2. And the kinetic energy at state 2 is 0 since the rocket comes to rest. At state 1, the potential energy is given by minus gm m by r, where r is the radius of Earth, plus kinetic energy, which is half m v naught squared, where v naught is the initial velocity of the rocket. So this is going to be equal to minus gmm by r plus h. Here we are considering h to be the height of the projectile. R plus h because when the rocket comes to state 2, the distance from the rocket to the center of mass of the planet is r plus h. So if we simplify this, 1 by r minus v naught squared by 2gm is equal to 1 by r plus h. So from this, 1 by r minus v naught squared by 2gm is equal to r plus h. So from this we write the value of h, which is the maximum height of the projectile, is equal to 1 by r minus v naught squared by 2gm minus r. Let's write the result again. H is equal to 1 by r minus v naught squared by 2gm minus r. Now let's substitute all the values. So this is going to be equal to 1 by radius of Earth is given to be 6.4 into 10 to the power 6 meters minus v naught is given 5 km per second, and in meter per second it becomes 5000 meter per second. So v naught square is going to be 2.5 into 10 to the power 7 by 2 times the mass of the Earth is given to be 6 into 10 to the power 24, and the value of g, we know it is 6.67 into 10 to the power minus 11 minus the radius of Earth, which is 6.4 into 10 to the power 6. After simplifying this mathematical expression, we are going to get the final result 1599,000.62 meters. So this is approximately 1599 kilometers. So the rocket's maximum height of projectile is going to be 1599 kilometers.